Hey folks, in this video, I'll introduce the idea of a topological sort. So a topological sort is basically a solution to our scheduling problem, right? So we had the scheduling problem where I have a bunch of things with dependencies, and I want to figure out what order I need to do them in. So the solution to that, right, is called a topological sort. And the actual name of the algorithm is topological sort as well, right? So the topological sort algorithm produces a topological sort. I know it's a little bit redundant, but that's the way we say it. So the topological sort, right, is basically an ordering those vertices such that the dependencies are seen before they're dependent, right? So that's what we talked about before. So let's take a look at this picture here. So I have basically a graph, and you can see that C, right, is something super basic, but C provides for D, D provides for A, D provides for B, right? So let's say I want that. What does a topological sort look like? A topological sort looks like an ordering of A, B, C, D, such that I see the dependencies before they're dependent, right? So I want to know what order to do those in. And there's different formats for these. One that I have here that's kind of nice to visually see is basically putting the nodes graphically, right? So I have here actually my ordering, and my ordering goes from right to left. Right, so the first thing here, my proposed topological sort, my solution to this scheduling problem for this graph on the left, is to have C first, right? And that's fine because C doesn't have anything coming in. C goes to D, goes to A, goes to B, right? So I'm reading this, C, D, A, B, right, as my solution here, right? And I can just look at my picture, and what I notice is I only have arrows going to my left, right? So C is done, then goes to D, then D goes to A and B, right? So I only have arrows going in one direction. That implies I have a valid topological sort because I'm just moving from one side to the other, right? I'm doing this stuff, then this stuff, then this stuff, then this stuff, and I never have to, backtrack to do something, right? Because all the arrows are going to the left, I know that I'm going to see something before I need to use it, okay? So this is a valid topological sort, and this is the kind of thing we want, right? And we want really just the ordering of C, D, A, and then B, right? And given that, right, I could draw this nice picture if we want. But we need to basically come up with an algorithm, right, to find this from an arbitrary input, right? Some graph that is a dependency graph. Okay, so a quick thing to think about here, right? And aren't you guys, do think about it, do pause the video and think about it. Do all directed graphs have a valid topological sort? Can we actually get this ordering of C, D, A, B, like for this example, can we actually get that answer for any possible directed graph as an input? So take 1 second, think about that. Can I do it all the time? So the answer is I can't. There is a certain class of graphs which I have a lot of trouble with. I'll just draw you guys one directly. So let's have the following graph. Now, something like this is fine, okay? Everything is good there. You could say this is A, B, C, D, right? And I can imagine there's all sorts of orders for doing like a graph like this, right? So probably I do like A, and probably I start with B, and I go from B to either A or C, and then I go to D, right? That's easy to do. The tricky type of graph, the graph we can't do, is the following one. Graphs with cycles in them. When you have a graph with a cycle, you have a cyclic dependency, there is no topological sort because you won't have any starting place, right? So like here, you have A, B, C, D, you have B, C, D. They're in a cycle, and so whenever you want to do one of them, you need to have done already one of the other ones. But the other one needs to have somebody else done, and then you get into this weird cycle thing where it's like, well, where do I start? There simply is no good place to start, right? No matter where I start, I'm going to have a dependent. I'm going to have a dependency, right? And that dependency will have its another dependency, which has another dependency, and eventually I'll roll back to myself, and I'll be faced with the same original problem again, okay? So only graphs without cycles can we actually find a topological sort for, right? So cycles are very bad. And so our next kind of discussion is going to be the following. How do I check to see whether a graph contains a cycle, right? So our goal is somehow to identify what we call DAGs, or directed acyclic graphs, right? So if I have a DAG, then I can do a topological sort on it. Okay, so our eventual thing, right, is of course we want to implement topological sort, but we just can't do it, right, until we take care of this. Right, we got to identify, does something have a loop in it, does it have a cycle in it, and only then, right, we'll be able to actually say, run me a topological sort on it, right. So we're going to take it's going to take us a little while to get to the algorithm to actually do this, right. First, we just got to know, is there a cycle in the graph?